this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic called dynamic programming. So what is dynamic programming? Dynamic programming, it is a method used in mathematics and also even in computer science to solve complex problems by breaking them down into simpler subproblems. By solving each subproblem only once and storing the results, it avoids redundant computations, leading to more efficient solutions for a wide range of problems. So let's see the introduction part. So dynamic programming is a general algorithm design technique for solving problems defined by or formulated as recurrences with overlapping sub-instances. Dynamic programming was originally developed by Richard Bellman in 1950s to solve optimization problems. So let's see what is the main idea behind the dynamic programming. So dynamic programming, the first thing is you have to set up a recurrence relation relating a solution to a larger instance to solutions of some smaller instances. The next one is to solve smaller instance once, then record the solutions in a table, extract solutions to the initial instance from the table. Let's see the application. So it is applicable when only subproblems are not independent, that is subproblems share the sum problems. So example, the examples of dynamic programming would be the combinations. So see how the combination looks. So it is a divide and conquer approach, would repeatedly solve the common subproblems. Dynamic programming solves each subproblem just only once and store the answers in a table, that is the tabulation method. So in dynamic programming we have two methods, one is memoization and the other one is tabulation. So memoization is top-down approach and tabulation is a bottom-up approach. So let's see the uses of these optimization problems. A set of choice must be made to get an optimal solution. Find a solution with the optimal value, minimum or maximum. There may be many solutions that lead to an optimal value. Our goal is to find an optimal solution. Let's see the characteristics and the dynamic programming algorithm. So first thing is to characterize the structure of an optimal solution, recursively define the value of an optimal solution, compute the value of an optimal solution in a bottom-up fashion, construct an optimal solution from computed information. So these are the characteristics of dynamic programming. An algorithm design method that can be used when solution to a problem may be viewed as the result of a sequence of decisions made. Dynamic programming algorithm stores results or solutions for smaller subproblems and looks them up rather than recomputing them when it needs later to solve larger problems. Typically applied to optimization problems. The dynamic programming mainly works on principles of optimality. An optimal sequence of decision has the property that whatever the initial state and a decision is, the remaining decision must constitute an optimal decision sequence with regard to the state resulting from the first one. Let's see what is the difference between a dynamic programming and the greedy method. So in greedy method only one decision sequence is ever generated. In dynamic programming many decision sequences may be generated. Next, the difference between the divide and conquer. So partition the problem into independent subproblems, solve the subproblem recursively and then combine the solutions to solve the original problem is divide and conquer strategy. Whereas dynamic programming, it is applicable only when the subproblem are not independent, that is when subproblems share subproblems. So the examples of dynamic programming may include the famous knapsack problem. So in famous knapsack problem we have dynamic programming solution, that is 0 bar 1 the knapsack problem, and when it is fractional knapsack we call it as greedy approach solution. So these are some examples of dynamic programming. So when we take the analysis it will be in theta of n log n. So let's see what are the advantages and disadvantages of dynamic programming. So in dynamic programming, since it uses the tabulation method, the optimal substructure means that we combine the results of subproblems to achieve the optimal solutions for the bigger one, and there is also another case called overlapping structure. The same subproblems are here or repeatedly in different parts of the problem is solved. So there are main two approaches in dynamic problem. One is top down approach, the other one is bottom up approach. So top down approach is also called as memoization, and bottom up approach is also called as tabulation. In the bottom up approach or the top down approach, both can be used in dynamic programming to solve problems. So this is how the dynamic programming is done. So if we see the applications of dynamic programming, so one is optimization. It is also used in the field of computer science, and then it is used in the field of operations research.